Hey Ray,
Hey, Will,
how's it going?
doing good. I am multitasking cooking right now.
Awesome. Glad you can come
Yeah,
by.
I'm streaming you on the big TV so I can see you though.
Oh, sweet.
That way I'll be paying attention. Yeah.
Hell yeah. Let's see if you can solve this brain teaser.
Oh,
Well, wait.
cool. What is this? Sneak peek into the lecture?
Yeah, still sneak peek. If you want, oh, you're the only one here. I'll show you the rest of the lecture. Wait, how do I get out of this? There we go. We got some cool things.
Okay.
Requests, response. We're gonna do some curl requests today. Use a little postman. I think it's gonna be a shorter lecture, so it'll be fun though. Some fundamental building blocks.
Yeah, exciting.
Yeah. What are you cooking?
We're making some fried rice.
Ooh, delicious.
Yeah. Do you cook a lot?
I cook a pretty good amount. Yeah. I think I made fried rice, chicken fried rice last week, which was really fun.
Yeah. We're making fried rice because we have like no other things to cook in our right now.
That sounds about right. It's easy.
Yeah.
All you need is rice and maybe an egg.
Hell yeah.
I'm gonna go fill up my
We're also
water.
putting some really spicy Thai chilies though.
Ooh, that'll make it good.
Yes.
That sounds delicious. All right. I'm gonna fill up my water. I'll be right back.
All right.
Welcome.
Okay, welcome everybody. It's 6:40 now. I'm just going to give it a couple more minutes to see any last minute people jump on in, and then we'll go ahead and start. Also, see if you guys can figure out this little brain teaser. Okay, I'm going to go ahead and get started. Hey everybody, my name is Will. A little bit about me. I'm a senior at Berkeley studying computer science, and this is my last semester. A year ago, I took this decal, and I'm in your shoes doing the same exact thing. And it's been joined the club the semester after, and then I'm now teaching this decal. So I really like this decal. I want this to be a good lecture for you guys. So if you guys have any questions during it, please ask them in the chat. I'll answer them as we go so everyone has a good understanding of what we're talking about as we go. For the brain teaser, those of you who said B, you guys are right. Adding these two pieces together and then twisting it by 90 degrees will give you B. So good job to the B people. So this lecture is going to be about backend 1. It's going to be your introduction to backend. We've talked about HTML before, CSS, and JavaScript. We've covered a little bit of front end with React, and now we're going to dive a little bit more into the backend here. So with that, we're going to talk about HTTP, what a RESTful API is, and then a little bit about Postman, which if you guys went to last lecture, we used that a little bit. And today I'll show you a little bit more about some of the tools inside of that. So to start off, HTTP is the language of the internet. It stands for Hypertext Transfer Protocol, and it's how different devices on the internet communicate with each other. It's kind of the standard for different internet devices to talk together, so each person on each end knows what they are saying. Because without any protocol, you'd just be sending bits over the internet. You won't know what those bits mean. So this is a way for any device to communicate with any other device. With these requests, if you go to a URL and make a request, type in the URL, what you're getting back is an HTTP response that's been formatted very pretty with CSS and JavaScript. And that's basically all the internet is. It's just HTTP requests, HTTP responses. So you've probably heard of HTTP and then also heard of HTTPS. And the difference between that is HTTPS is Hypertext Transfer Protocol Secure. All that really means is they use something called a TLS handshake, which is a transport layer security, I'm pretty sure. And that's just an extra step when you talk to a server so that your data is now encrypted. So only you and the server know what you guys are saying. That's basically the de facto standard now. Any website you go to will use HTTPS instead of HTTP. That way, anybody on the network between the server and you won't know what you're saying. So as you saw before in the last lecture, there are a couple different types of requests that you can make using HTTP. The most common one is going to be a GET request, where if you type in a URL into your browser, what you get back is going to be the results of a GET request. So if you go to wikipedia.com, you're making a GET request to wikipedia.com and getting back HTML as the response. The next one is a POST request, which is when you want to upload something to the server you're talking to. If, for example, you're making an account on a website, you're going to basically send them a POST request that then uploads your account data, and then the response back will be either a yes, that worked, or a no, that didn't get posted. Next is a PUT request, which is very similar to a POST request, except the goal of that is to update an already existing data in the server. So if you're changing your username on an account, that would be a PUT request to the server, where the data is being updated on the server, but not necessarily creating a whole new data profile for yourself. And finally, the last of the 4 common ones is a delete request, where you're deleting something off of a server. These are kind of the standard ways to use these requests. Technically, you don't have to follow that. You can make a GET request that updates things, but that's really not what you should do. You kind of want to follow these standards when you're making a backend. So like I said, for example, if you want to get a list of books, that'd be like, for example, a GET request / books. Deleting a specific book would be a delete request / books / book ID. And then there is a difference between a GET request to /books and a POST request to /books. Those mean 2 totally different things on the back end when you're implementing your backend server. And same for a PUT request with an ID and a GET request with an ID. So deletes a book, creates a book, update. Yeah. So in these requests, it may seem a little abstract right now, but we'll do a live example in a second where this will become a lot more clear. But there's a certain response that you're going to get back when you make these requests that is pretty standardized to let the client know if it's been a successful request or an unsuccessful one. And there's a lot of things here for a lot of different types of responses you can get, but these starred ones are the most important ones that actually matter. So every time you make a successful request, you're going to get a 200 response back, and that's the server telling you, we got your request, we did everything you should be done. Here's saying you did a good job. Similarly, a 201 is if you created data for a POST request, that'll give you a 201 response back. 204 is going to something that doesn't have any content on it. And then in the 300s is the type of redirection responses you might get. So those are kind of moving you around. Say, for example, you go to HTTP without the S on Instagram. That's going to then give you a 300 response back to redirect you to the HTTPS website, because they don't want anybody using HTTP anymore. Similarly, the 400 series is for things where you did something wrong on your end. So if you're making a request and you put in a parameter wrong or a query parameter wrong, that's going to give you a 400 type of request where you did something wrong. And the last kind of series you need to know about is the 500, where a 500 error is going to be something on the server side went wrong. So you may have done everything right on your end, made the right request, but if there was a bug in the server side's code, then you would get a response back with a 500 series. Looking at the chat, are these standards we can redefine, or are these predefined? These standards are pretty predefined right now. If you want to learn more about this, I would look up HTTP response status codes, and Mozilla is kind of a really great resource for backend to learn more about all these different standards. If you're going to work for a company, you definitely want to follow this practice and use the right responses in the right for the right circumstances. I also see when we download a 10 gigabyte file, can we use a GET request? Yeah, you can. So usually for that big of a file, there could be different file transfer protocols you have, but a GET request would definitely work in that situation too. Okay, so now to make a request, this is going to be a little more hands-on instead of me just presenting onto you. So I'm going to get out of this. How do I get out of this? There we go. So inside of everyone's browser, if you go to your terminal page right here, let's see, you can make a curl use the curl command to make a request to any website. So curl is a pre-built-in function into your computer that basically every computer has. And it's kind of the standard way to simulate what a browser request is doing. So if we use this, for example, this is an API called Poke API, which I have open right here. And it's a RESTful, which we'll talk about in a sec, API where you can get a bunch of data about different Pokemon. That's the idea of it. So their URL right here is https pokeapi/API version 2. And then they're also specifying Pokemon and a ditto here. So we'll talk about a little bit more of what all this means, but this, if we type this into our terminal, where we did a curl request, and then this, can I post the link in the chat? Yeah, sure. Here's the link to that request right there. And here's the link to the API, the main website. So if you're doing a curl command on a website, what you're gonna get back is a ton of data. And what this represents is this is the data, this is the HTML of the website basically. So this would be the same thing. See all this data, we have abilities, Limber, a bunch of different fields in here, they're all kind of random. But if you go to the link that we did the curl request on, it's exactly what you see on the website. So a curl request is giving you the same thing as what the data itself is when you make a normal search online. So in another sense, say for example, we have this Wikipedia page right here, which talks about the history of curl, what it is and everything like that. If we want to make a request to this, if we do a curl request to this, we're actually going to get back that raw HTML. So you can see the doc types HTML, all your classes. If you did this to any of your websites that you would have made, it would give you back the HTML that makes that website. So that's what HTTP really is what's the protocol for sending and receiving HTML so we can build websites. So we'll get back to curl in a second. Let me present this again. So in that HTTP request, kind of like going to a website, we have the protocol that's defined at the beginning. So HTTP versus HTTPS for the secure version. Then we have the host name, which starts with a subdomain right here, then the domain of the host, and then the ending of the host. And then if we're looking for specific things on the website, that's where this resource/file path comes in. This should be pretty familiar if you've gone and searched for different things. This is a very standard format. And then what's more specific is this query string. So this starts with a question mark. And if we want a specific thing from a website, we can specify query parameters to pass to the website. So in this example, if we want the response with an ID equals 1 and topic equals 2, we can pass these parameters to the server. The server, which is like the backend that we implement, will be able to take these parameters from the query string and then process them in a way and return a response that is symbolic of what the query is representing. So to demonstrate that a little bit, I have a different link for the Poke API. You can see down here, there's this Pokemon limit equals 1000 and offset equals 0. So this is an example of making a request to the Pokemon version. And then here's our query string again, where we're limiting ourselves to that 100,000 Pokemon and starting at the first Pokemon in that list. So if we took this and made a curl request to this instead, let me type this in correctly. You can see here it's the same thing. Then what this is going to give us is a list of all the Pokemon here. So you can see name is Bulbasaur, Ivysaur, Charmeleon, all the Pokemon, the first 100,000 Pokemon. Yeah, I can post the link to this one too. So here's that website. And just again, the same thing if you're doing a curl request. If you put it into your own browser, you'd get the same exact thing back. Okay. So in these requests too, there's different parameters that you kind of aren't seeing. This is what a HTTP response looks like to the server itself. So at the beginning, we have the post method specified, which is one of the 4 methods that we talked about at the beginning. This is the resource indicator here, which is the string afterwards right here, the file path for what we're accessing from the server. And then we also have to specify the HTTP version, what version of the protocol we're going to use, because the server needs to know that we're using the same version so it can align the rest of the contents and understand what we're trying to tell it. Inside here are different headers that we're sending the server. These can specify different metadata about our request. They can respond to specify what type of content we want back from the server. So it could specify what browser we're using. There's tons and tons of headers we can specify, and that would all go in the header section. And then down here is the body of our request. So if we're posting a create user request, this is representing JSON about the name of the user that we want to create, and then also his age down here. So to see this in a live setting, we can use curl and then use some of the curl options that they include. So for example, if we do curl-v, that stands for a verbose version of curl, which means it's going to give us the more metadata about the curl request. So if we do a curl request with our verbose option to this URL right here, it'll generate the same as before, where we have all the HTML code that goes into the website. But at the very beginning, we have a bunch more information up here that's a lot more specific. So for example, we can see here that we're using HTTP version 2 instead of version 1. The status code that we got back from the server is 200, which means that we got an okay response from the server. We can see things like X content type. There's authorization going on the website. Up here is our TLS handshake, which if you've taken 161 computer security or 168 internet architecture and protocols, they'll go a lot more in depth about how this secure handshake works. And this is basically saying that we talk to the server, they talk to us, and now we are able to encrypt all our data without anybody else seeing it. And then there's lots and lots of more metadata about this. I think one more interesting thing to see with that is if we do a curl request to this API again, with the verbose mode, we can see an interesting header from them. If we go back up to the top, they have the header here, X powered by Express. And so what that's basically telling us is their backend is using Express to host their backend. So we know they're running a node backend using the client Express, which is kind of interesting, kind of telling about what that server is using. And you can find a lot more metadata about different servers this way by looking at these different header fields. Okay, let's go back to here. So this is an example of a response you might get back from a server. Here in the body of the response, we can have data sent back to the client. And this data can be used to fill in different fields on a website. And it can also be used to just respond to our request with what we wanted back from them. So here we can see that it says status was a success. We wanted some min and max data, maybe some random numbers in that sequence. And then we can also have more objects inside of objects being passed back. So this is an example of a front-end request to a website. When we do a lot of front-end requests, we're going to use Axios for that. And this is an example of doing a GET request to this example website. And then with that response, we are processing what its status code is, and then also logging its response. And then, for example, if we want to do a post request, we can also include a body inside of the post request that we want to send. So to our to-do list, we're going to post buy the milk, and then we can then get a response back from the server. That gives us our status code and then logging this response itself. So here's kind of a more detailed view about how an HTTP request gets processed by a server. You definitely don't need to understand all of this. It's pretty advanced stuff that most of the time you won't be using all these different parts of a project. So the main thing is that an HTTP request first goes to a route, which you specify on your backend, and then that gets forwarded to the appropriate controller for the route, which kind of handles the request, dissects different data from it, if there's query parameters in it. And with that, we could then talk to our database through some models that represent what our data looks like. And this is how we can get data back to send to the client, update data in the database. And then there's also views we can consider if, for example, you're going to a Wikipedia page and you want to return that HTTP code, we can return that from a different template that we have saved here. All that together gets packaged up and sent back into a response back to the client. So another perspective of the same thing, we have the request coming into the router, that's in HTTP. The controller then processes the HTTP request, getting the parameters and everything, knowing which resource we should locate. And then that's where we get handled to our business logic, which is more of the code of the backend of if, for example, we're on Google Maps and want to request some details about a restaurant, that would be handled back here. Once we know the name of the restaurant, where it is and all that stuff, we would then interact with our database, or maybe call an external API to Yelp's API and get how many stars it has and some reviews from it, bundle that all back up, and then send that back as an HTTP response. So inside of a backend database, or inside of a backend website, this is some of the structure you might see. You would have your app, which is the main entry point for your application. You could define some routes in another folder, some environment variables, loaders for different modules, some models that represent your data, which you'll learn about more next week. Some of the business logic inside of it, any asynchronous events that might happen, and then also other long scripts that might run. This isn't a standard you have to follow. This is just an example of what that might look like on the back end. Okay. If there's any questions about that, please let me know, because I know that was a lot. If you do think of anything, feel free to drop it in the chat, and I'll respond to that as I talk about what a RESTful API is. So you've probably heard the term RESTful before. What that stands for is representational state transfer. And it's basically just a way to structure an API endpoint so that it's you as a client, you know what to expect from that endpoint. So it's kind of a list of rules that you should follow if you're making a backend website and you want it to be considered RESTful. So some of the rules, we'll go through all of them here. There's about 6. The first is called client server. And what that basically means is you want to separate the user interface concerns from the data storage concerns. So on the client side, you want the client to be able to access your RESTful API no matter what device it is. So your API should handle all the intense logic, all of the things that take a long time to run, any business logic, that should all be on your server. And so the client just has to make a simple request to the server, let the server deal with that, and then get his response back. Next is stateless, and each request from the client to server must contain all the information necessary to understand the request. So for example, if you have cookies on a website, those cookies are on the client side and they store data about the client in the form of a token usually. And those cookies on each one of your requests are being sent back to the server to verify that you are who you say you are. And that's an example of having a stateless API, where each time you make a request to a server, you're providing all the details that the server needs to know to respond to your request. And you're not assuming that the server knows anything about you just through the HTTP request. Next is cacheable. Each API endpoint you make should either specify if it can be cacheable or not cacheable. For those of you who don't know what cacheable means, it basically means if you make the same request twice, then you should get the same response back twice using the same parameters. So if that's the case, for example, if you're saying what's 1 + 1, that's always going to be 2 no matter what. So the server, the client can cache that as a response and won't have to actually make that request multiple times in a row. Similarly, uniform interface, there's multiple architectural constraints are needed to guide the behavior of components. So it should be a standard form that you should lay out your API endpoints in. Next is layered system. The layered system style allows an architecture to be composed of hierarchical layers by constraining component behavior, such that each component cannot see beyond the immediate layer with which they are interacting. This is kind of a way to separate the logic going on in your code so you aren't kind of having different interactions with different parts of your code that aren't necessary. And then lastly is an optional one for being a RESTful API, which is code on demand. And that basically just allows client functionality to be extended by downloading and executing code in the form of applets or scripts. This really isn't as applicable nowadays anymore. So that's why it's kind of optional in today's day and age. So now we'll talk a little bit about Postman. For those of you who were at last lecture, I know they demoed it a little bit. Postman, it's a tool, it's an app that you can use to test different API endpoints. And it gives you a lot of detailed data about that endpoint. And it is basically the de facto standard for testing your endpoints. So if you guys haven't installed Postman yet, I highly recommend it. It's going to be very useful for the upcoming final project that you do, and then any backend development you do at all, because you'll be able to see a lot more data a lot more clearly than just using curl requests. So let me show you Postman. Oh, I see a question. What's the difference between using GET request to get a front-end HTML file and get JSON data from a server? So when you make a GET request, it's basically, to answer your question, it's basically the same thing. So what determines if you get HTML or JSON data from a server is what the server sends back in the GET request. So for example, in our Pokemon API here, if we did this Pokemon request for Ditto again, oops, I forgot this part. If we did this request for that we made in curl earlier, this would just be in JSON data, JSON form. And that's the decision of the server to return that in a JSON format. But when we did the curl request for Wikipedia, what Wikipedia wants you to see when you make a GET request to this endpoint is this website right here. So that's the server deciding to return you HTTP instead of JSON. When you make your own endpoints, you can also make that decision of what you want the user to see. If the path is / how does the server, if it's HTML file request or JSON data? Like I said, I kind of answered this earlier, or in the question before. It's really up to the server to determine what they want to send back. So you can have one endpoint send HTML and have another endpoint, like if I did ditto /2, that could return an entirely different thing. Is Postman then just to kind of dashboard to better understand different HTTP requests? Yeah, that's basically what it is. It's a pretty dashboard that lets you make HTTP requests without having to use curl and having to deal with unformatted data. So this is what it kind of looks like when you have it opened up. You can see here where you want to make a GET request. And then here's the same request that we made earlier, which is a request to list the first 100,000 Pokemon with an offset of 0. So what's nice about Postman is you're able to see a lot more data about the request than just scrolling through curl requests. You can see right here, we have a 200 status code of OK, gives you a little description about what that means, which is very useful to understand. We have the time that it took for the request. all broken down. This is called a waterfall chart. And it kind of breaks down the different parts of your request. So you can time out, maybe if you're doing something on the back end that takes a really long time, this would be able to show you that. So we can see here that the TCP, these two layers are for HTTPS, which is doing our TCP handshake and then getting a SSL handshake. And then this is when our data is being downloaded down here, which only took 5 milliseconds, excuse me. So that's really useful for testing your own APIs to see if something is taking a really long time on your end, and if there's maybe a different way to do that that could be a little more optimal. And then down here, we have a body that lists out exactly what we saw earlier on the website itself, but in a lot more formatted version. In chat, if I use curl google.com, I get lots of numbers and text instead of a website. How does the client know if it's a website and display it? Okay, let's actually try this out. Let's see. So here we're gonna, if you click up here, you can add a new request to test out. We're gonna make a GET request to google.com. See what we get. So here we have an HTML response, which you can see from the top right here. Has some metadata, some scripts that are running on the server side, different variables. This is just inline JavaScript, as you can see right here. Then it has the CSS styling also being returned right here. And then more JavaScript down here. Here's the body of the page. And these are all the things you'd see if you went to Google. The play button, YouTube, Gmail, all these things. So this is the HTML, CSS, and JavaScript of a Google page, which is pretty interesting. You said you got lots of numbers and text. That's probably what's going on in the middle of these random JavaScript things. I have no idea what these do, but I'm sure Google does. How do you find the link for an API of a site? Did you just Google it or something? So that's actually a good question. A lot of the time, you don't want anybody to find your APIs if you're using one for your website. For example, say you are Google and you have an internal API to get data from that fills in the different routes you can take for a Google Maps or where all your different locations are. You don't really want other people to have access to that, because then they can start spamming your API and flooding it with requests to slow it down. Or you could also then just use their API to make your own version of it. So usually you can set in an API who has access to it and what different IP addresses can access it. And you would set your front end to only be able to access your API and no other websites. But if there's other examples of API, for example, like this Pokey API down here, this is an API that they want everyone to have access to. And to find that, you kind of do just Google for it. Or if I wanted to find an API for elevation data, I can just look up API elevation data. And there's usually a couple different free APIs. Like, oh, Google has an elevation API right here. And so you can go through here and use their API. So back to Postman right here. Here's the original request that we were talking about earlier with the limit 100,000 offset 0. Here you can also see the headers. And this is a great way to understand more about the metadata going on in your request. So we can see here, it returned an application.json content type, which is kind of similar to the question you were asking earlier, is how do we know to display it as JSON or HTML? That would be specified right here. And then, as I was saying too, access control allow origin. It actually gives you a little info right here. What this does is it specifies who the API is allowed to talk to. So a star means that it's allowed to talk to anybody. But for example, if we only wanted it to be able to talk to us on the back end, we can specify here what IP that we should talk to. And then there's a bunch of other data around here in a well-formatted way. We can see that using Cloudflare to host their websites. Here's an endpoint that they report to. I honestly, I don't know what most of these things do. There's just so many different headers, but they're a great way to better understand the data that you're requesting. Here at the top, we can see the headers that we send to the website. So these would be called request headers, and down here are the response headers. These are showing who we are. We're telling the server that we are running in Postman. We're accepting different versions of encoding it, of encoding the response back, basically like compressing it with gzip and stuff like that. This host is also kind of a request that identifies who we are in a way. And servers use that a lot to kind of track us a lot across different websites and stuff like that. And then if we're going to make a GET request, for example, if we put, I'm sorry, a post request, we can put a body here. So we can do something like raw, and then if we wanted to, we can, in our post request, we can say name is John. Oops. And age is 25, like before that we saw earlier in the slideshow. So highly recommend just playing around with Postman, learn different tools that it has, different versions, different utilities you can have with it. And it's a great way to kind of play around with testing your own APIs and then also testing out public APIs that you might want to use in the future. Last thing here is the query parameters start after this question mark, and we can see them get auto filled in right down here. So if we wanted another query parameter, maybe like Pokemon, we can put it in here and it'll get automatically placed into the string up here. Question in chat, are cookies saved on the front end of a site in the API, or is it held by Chrome or something? So cookies are saved by the browser. Let me see if I can show you a good example of that. If I inspect any website that I'm on, we can pull up all like the developer tools for inspecting the website. So it gives you a console elements, but if you go over here to application, you can then see what kind of data is being told to the website about you. So these are kind of more advanced things that you might learn about later. Local storage is different types of storage that the front end can use to save information. Same with session storage. The difference between these two is session storage gets wiped after you close a browser tab, and local storage will persist across browser tabs. So this could be useful if you want to save like inside of a tic-tac-toe game where the user is, you can save that in local storage. So if they close the tab, they can reopen it and that data will still be there. And then these cookies you can see are being stored on the front end as well. So the browser, if I open this, you can see all the different cookies that Google has on me. Hopefully there's nothing important in here, but this can tell you what the name of the cookie is, what its value is, which is just some encoded string that only Google knows what means. And then you can also see other information about it, what domain has access to your cookie, and different information about that. Okay. That basically wraps up what I wanted to talk about for backend 1. If there's any other questions, please type them in the chat or just let me know. I'll be able to stick around for another 10 minutes. But if not, thank you very much for listening. And I hope this got you a little bit excited about working with backend, because the applications for it are very cool. And there's a lot of different things you can do and a lot of different websites you can make. So thank you very much and enjoy the rest of your day. Thank you, everybody. I'm glad you guys enjoyed it. Can you elaborate on the local storage again? Yeah, sure. So here, I can't think of a website off the top of my head that has locals. Actually, I do know one. If we go to CS161, CX161's website, I hope they still have this here. Oh, I don't think they do. But in the past, you're able to specify if you want like a dark mode or light mode on the website. So if the user wants dark mode as their preference, you can save that in this application local storage right here. Actually, there's other local storage they have, which is interesting. So the main idea of local storage is it's a way for a website to remember things about your computer. And that will persist when you close the tab, close the browser, and then reopen it. So you can see that CS161 wants to remember my device ID and user ID for some reason. I don't know what they use that for. And then other little session details as well. And then session storage, this is storage that the front end could use for your active session. So a session is basically when you have a browser window open, a browser tab, and when you close that tab, this session storage will get wiped. Yeah, so the local storage data never gets lost until we delete it. That's correct. So that storage will just persist there until either I could right now, if I wanted to, I can change these properties. I can just get rid of these and just delete that. And now they don't know about that anymore. Of course, they can remake that again, but either it can be deleted by the user, or the front end can manipulate it, modify it, and delete it if they wanted to as well. Yeah, of course. I'm glad you guys enjoyed the presentation. That was fun. If there's anything else you're curious about, please let me know. During the summer, I basically did full stack development all summer, so I can give you some real world experience if you want anything. Okay, if I develop a React app, how can I integrate that into a server? So are you basically asking, if I develop a React app, which is the front end, how can I integrate that and have it talk to my backend, which is the server? Is that what you're curious about? I mean, do we have to include React app in server code? Okay, that's a good question. So the answer to that is no. The React is going to be your front end code, which is kind of going to be what the user sees. And then backend code, the server code, is going to be what the front end talks to. So let's see if I can show you an example. That would be easy. I can just open up something real quick. Let me go to here. This is some project I was working on. This is backend code. This might be confusing because it's in Python, but all the code back here are different endpoints that the server talks to. So this is all specified here with the routes, and the front end would then make requests to this backend, and that's how the front end would get its responses and get the data it needs. So in React, you would use Axios, which I think we showed a little bit earlier here. So you'd make a request to what your backend server is running on, this HTTP, and then that response would be how you talk to your server. And the server would be able to send a response back to you about that Axios request, about what you want from the front end. So the server code is going to be usually written in Node.js. That's the most popular. And that's what we'll teach this semester. Awesome. Of course, I'm glad I could help. Yeah, you too. Okay. Bye, everybody. I hope you have a good day.